So let's understand for today's session. So what is Hive, and we'll try to see something about Hive. Okay. As I was discussing, so Hive is a ecosystem. Or Hive is one of the ecosystem which is built on top of Hadoop, or which is an additional ecosystem which is provided, which gives us the facilities or features to write some SQL queries. Okay. So Hive is a warehouse system, or to be precise, a data warehouse system, okay, for data summarization. Okay, for data summarization you can say, or for analysis, or you can say, and for querying. Okay, for querying of large data. Okay, now let's see. What we have seen till now is we were bringing the data from relational databases and dumping the data into the HDFS file system, and we were just able to see the data. Okay, as of now we were not doing any processing on top of that data, which means that I was not able to do some analysis, or I was not able to do some summarization. So I was just able to see the entire dump of the data with the help of some Unix commands, or with the help of some HDFS commands, correct? But what if a scenario comes, I want to find how many records are there, I want to find out the count, I want to do some analysis, or I want to do some data warehouse summarization like how we do in ETL tools. If that scenario comes, how I can do that? Yes, I can do that. Why? Because this person or this tool helps me to do that. Why? Because it's a data warehouse system for data warehouse, for summarization, analysis, and querying of large data. Okay. The second thing is, it this is a very important, same like scoop command. It converts your SQL like queries into MapReduce program. Okay. So what it does, whenever we are writing .hql or HQL queries, which is nothing but Hive query language, so that is nothing but similar to your SQL syntaxes. There will be small change here and there, but that is manageable. But you will find more of a flavor of SQL like queries. So it converts your SQL like queries into your MapReduce jobs for easy execution and processing. Okay, because let's take an example. We are not so strong, or we are not so confident in writing the Java programs. Okay, so the same scenario happened with the people who were working in the Facebook. Let's take an example. Why Hive came into picture? Okay, so why Hive came into picture? So because there was an organization with the name called Facebook, and we all know Facebook. Okay, so what Facebook is, we all know, it's like a social networking platform where we try to post our uh, where we try to post something related to some topics. Okay, we try to upload some audio images like GIFs, like video images, etc, etc. So it's like a social networking platform. So whoever are my friends, once I post something, they are able to see that, and so on. Okay, so I'll not go into that details. But what Facebook had a challenge was, Facebook was not Facebook was, when they means when the data was available at Facebook, like in petabytes or exabytes, they were not able to write. They had to do simple what you say, let's say they wanted to do some data summarization or analysis. So to do some data analyzation or summarization or analysis, they had to write lengthy piece of codes, and people available in Facebook were not so familiar, or they didn't had many resources who can do this programming paradigm. So they had this challenge. So even to do simple summarization, they had to do thousands lines of coding, and then they were able to do certain summarization or analysis. So they were facing a challenge. So when they were facing the challenge, what Facebook did is Facebook came up with a tool. They started developing a tool because in Facebook corporation there were people who were heavily used to your SQL like queries or procedure language. So what Facebook did is Facebook came up with a tool called Hive. Okay, so before that, so let's start. We have started there. So Facebook had as I told you, Facebook was facing a challenge. Why they were facing a challenge? Facebook was facing a challenge, and what was the challenge? To implement solutions like data analysis, or let's say summarization. Okay, so they were facing challenge to do data analysis or summarization before implementation or implementation of Hive. Why they were facing the challenges? Because the size of the data was humongous. Okay, we all know the Facebook, how they process the data, and what is the volume of the data, and the variety and of the data, and the veracity. So we all know these terms. We have seen in Hadoop: volume, variety, and veracity. Okay, so the data is not in a consistent format. It's in a wide format like audio, video, GIFs, comments. Those are like random comments. Okay, the volume, it's like in exabytes, petabytes, maybe in brontobytes as well. Okay, nowadays. Okay, so Facebook was facing a lot of challenge because the size of data was humongous. Okay, so size of data was humongous, or size of data was too large. Okay, and it was exploding day by day, and it was becoming difficult. Okay, it was becoming difficult for them to handle that. It was becoming difficult to handle that with the help of programming paradigm. So they were facing this challenge. So what Facebook did is Facebook invented, people were mostly available or mostly known with the traditional knowledge of sequels. So what they came up with, they came up to overcome this problem of programming paradigm or writing the MapReduce program, which will do your summarization and analysis. Okay, so what they did is they started developing this tool at the back end, and they developed a tool. Okay, so they developed a tool which was named Hive. Okay, where you can write SQL like queries. Okay, once they developed this tool, okay, what they did is, as we all know, whenever we execute the Hive queries, okay, so what Hive does is Hive internally converts your SQL queries into MapReduce program, and your work is completed. Okay, now you don't need to write lengthy pieces of code. So same 1,000 lines of code can be achieved in, let's say, 60 lines of SQL queries or 40 lines of queries. Okay, so that's how Hive came into picture. So what Hive does is Hive reduces the complexity of writing MapReduce programs. Okay, it reduces the complexity by writing simple SQL like queries. Okay, by how? By providing an interface. Okay, I can say an interface, or I can say a wrapper. Okay, by providing an interface where user can write queries and submit those queries, okay, which will be internally converted to a MapReduce program. Okay, so that's how the evolution of Hive was done. So let's come back. Hive is a data warehousing system which is used for data warehouse summarization. It is for analysis and for querying large of data. It converts your SQL-like queries into your MapReduce program for execution or processing. Okay, either you can say execution or processing. Okay, Hive can process your semi-structured and structured data using a SQL-like query language, which is also known as .hql, or which is also known as HQL, which is nothing but Hive query language. Okay, so these are the 3 pointers which you'll have to remember. It's a data warehouse system, or it's a data warehouse ecosystem used for data summarization. It is used for analysis or for querying of large data which are residing in my HDFS file system. It converts your SQL-like queries into your MapReduce program. Okay. The third thing is it can process your semi-structured and structured data, which can be internally converted into MapReduce program with the help of SQL-like queries, which are nothing but my HQL in Hive. Okay. This is a very important pointer. We need to remember that Hive is not a database. Okay. Definitely we are writing a SQL-like queries, but where is the data getting stored? The data is getting stored in the HDFS file system. We are using an interface on top of that HDFS file system, or a wrapper on top of that file system, that is nothing but Hive. So it's a data warehouse system used for summarization or analysis or querying of large data. Always remember these 3 things. So it's not a database. Okay. It is also, Hive is not designed for OLTP systems. We all know what is OLTP systems. These are your online transaction processing, wherein your frequent inserts and updates are happening. Okay. So Hive is not designed for OLTP systems. Okay. So as is not designed for OLTP system, okay, so Hive is not a language, okay, for real-time queries and row level updates, as I just told you. Yes, Hive provides a functionality where with certain properties I can use my insert and updates, but predominantly it's not an OLTP system. So these 3 pointers you'll have to remember. It's not a database. It's not designed for OLTP systems, wherein you can execute your frequent real-time queries, which are nothing but my DML called inserts and updates. Okay, it's a tool, or it's a ecosystem which is used for summarization, data summarization to be precise, and for analysis and for querying of large data. Internally converts to a MapReduce jobs which are getting executed, or which helps in my execution and processing. It can process this type of data, which is nothing but structured and semi-structured. Okay, and we all know why Hive came into picture, because there were some Facebook developers which they were facing some challenges, as even for small summarization of a querying of, or let's say data analysis, they had to write a lengthy piece of code in MapReduce programming paradigm. So to overcome that, they came up with a tool called Hive, wherein they can write simple, or they can write SQL-like queries which their developers are very used to, and internally there's SQL-like queries with an interface called HUE or Hive CLI, when they used to submit, that used to get ready converted into your MapReduce program. Okay, so that's what we'll need to remember. Any questions in this small introduction?
No, Saif.
Okay, if no questions, then we'll try to see a small architecture, that is, sorry, we'll try to see the Hive architecture, how the Hive architecture looks like. Okay, so it's a small architecture, it's not a big architecture, just good to know what happens internally. Okay, let's try to understand the Hive architecture. Okay, so let's take an example. There is a request, and we all know now where the request would be coming from. The request would be coming from either from a client, right? We all know what is client now. So the client is nothing but the edge node. Okay, so from the edge node we were executing our scoop commands. When their scoop commands were getting executed, it was internally converting the MapReduce program, and in that MapReduce program, with the help of JDBC connection, it was trying to connect with my relational database. It was doing the data ingestion. So when it was doing the data ingestion, so there was like a serialization which was happening, which means that my Java objects were getting transformed into stream of bytes to store into my HDFS file system, and finally that data was getting stored into my HDFS file system. Correct? So that was happening. Now, same way, when the request is sent by the client, okay, so let me just write client over here. When the request is sent by the client, so now client can be of three types. Okay, so the first thing is nothing but Hive CLI. So what is Hive CLI? So Hive CLI is nothing but command line interface. Okay, you all see that black screen. Okay, so that is nothing but the command line interface. Okay, the second thing is nothing but Hive UI. So Hive UI is nothing but, so I will say Hive Web UI to be precise. Okay, let me say that Hive Web UI. So we have an interface which is in the form of graphical also. Okay, and that graphical interface is nothing but, what is that graphical interface? That is nothing but you. Okay, we all know that. So let me just write in a little. So first thing is nothing but my Hive CLI, as I told you, Hive command line interface. The second thing is nothing but Hive Web UI. Okay, so Hive Web UI, the second is, and that is nothing but my U. What is U? Hadoop user experience. Remember how we try to see the file system in a Web UI format on a port called :50070. Remember how we go to the browser, we enter the IP address, colon,
Yeah.
and the port. Same way, we can see the Web UI also with the port name number called 8888. Okay. The third thing is nothing but a thrift server. Okay. So what is a thrift server? So I'll explain you. It's a client connectivity. I'll tell you later. As of now, just understand there are three things which are available, and I'll show you all these three things, which, and mostly we'll try to use Hive CLI or Thrift Server. Okay, I'll not be using the Web UI because, yeah, you can use Web UI, because I'm not so comfortable using Web UI because I am always comfortable with the black screen, so I'll be using black screen. But these are the three options from where a request can come to a Hive. Okay, Hive CLI, either from a Web UI or either from a Thrift Server. Okay, cool. So once the request is coming, where the request is sent? The request is sent to a driver program. Where the request is sent? The request is sent to a driver. Okay, so there is a driver. Now what this driver does is, okay, so once you are sending the request, from client, the request is sent where? The request is sent to the driver. Okay, so at client, what you are writing? You are writing SQL like queries, right? Okay, and this SQL like queries are submitted, or request is sent from your client tool to your driver program. So once the request is sent, so what this driver does is, it takes this queries, okay, it takes these queries and whatever APIs are required to convert this SQL like queries into MapReduce program with the help of JDBC ODBC connections or JDBC ODBC parameters. It tries to convert that queries into a MapReduce program. So what is the job of driver? The job of the driver is to take your input or take a request from a client, which will be SQL like queries, and convert those queries into a MapReduce program. That is the job of your driver program. And what driver will do? It will take, with the help of the required APIs, which will be used to convert your SQL like queries into your MapReduce program. Okay, so what happens here? Whatever SQL like queries which are sent to your driver program, they are converted to a internally they are converted to a program which is nothing called MapReduce. Okay, now when they are converted to a program, okay, so they are internally converted. The third thing is, there should be a sorry now when they are converted, the third person comes into picture, and that person is nothing but your compiler. Okay, so what this compiler does? This compiler does is nothing but the semantic and syntactical errors checking. Okay, so what are the two things? So we know whenever the code gets compiled, we get the errors, if the like syntactical or semantic errors, remember. So here the syntactical and semantic errors, so just give the typo error that could be. So what happens is, when the request is sent ahead to the compiler, okay, so whatever the program it had, so there are a couple of checks which are applied. And what are those checks? Those checks are nothing but syntactical and semantical check. Okay, so syntactical check, so what compiler does, it compiles the program with the help of syntactical checks. So whatever the code is written, whatever the code is converted, is it correct or not, which corresponds to your internal MapReduce program. And to do some semantic checks, there is a place or there is a person which is nothing but a person which is called metastore. Okay, so we will be seeing metastore. So for doing a semantic checks, it takes a help of your metastore, because all the metadata is stored in your metastore. We all know what is a metastore, data about the data. Okay, so what compiler does, it needs to perform syntactical and semantical analysis. What it needs to perform? It needs to perform syntactical and semantical analysis, and that is performed by compiler, and it takes help of your metastore. Okay, so the SQL like queries are coming, converted into a MapReduce program, it is compiled, and it is being syntactically and semantically analyzed. So once this is parsed, then the further execution happens, this is sent to an execution engine. Where it is sent? It is sent to an execution engine. Okay, so there are various execution engines are available with Hive. Okay, so that supports so like there is a like Days, Storm, and Hive also is one of your engine which you use internally. Okay, now when this semantic compilation is done, it is being sent ahead to process in the execution engine. Now whatever this thing is happening, this everything is happening, whatever this thing was happened that was performed, where that was performed? That was performed in Hive. Okay, so what exactly? So the request came from client, the internal conversion of SQL-like queries into MapReduce program, the compiler, and the execution. Now the data needs to be processed, right? Because that has been converted into MapReduce program, the execution engine is ready to process the data. Okay, so the Hive does not process the data. Okay, who processes the data? Your Hadoop processes the data. Who processes the data? Your Hadoop processes the data. So this is a layer, and that is the nothing but your Hadoop layer. Okay, so this is your Hadoop layer. So what happens from here? The request is sent to your Hadoop. Where the request is sent? The request is sent to Hadoop. And we all know the Hadoop 1.x architecture. There is a name node, there are multiple data nodes. Okay, how the parallelism is happening, how the blocks are written. Okay, how the replication is happening, etc, etc. So this is nothing but your name node. These are nothing but your data node 1, data node 2, and data node 3. Okay, all the things which will happen, which means that the request will be sent to your Hadoop. Name node will see, because name node is responsible for doing the metadata management and the cluster management. So what name node will do, it will try to see, or it will try to allocate. Okay, so this block is written here, let's say this block is written here, some blocks are written here, depending on each area. And we all know blocks are written parallelly, and replication is done sequentially. Okay, so underlying the data will be processed in your Hadoop with the help of name node and data node. Once the data is processed, okay, once the data is processed, the data would be sent back to your execution engine. From the execution engine, the data would be sent back to the driver, and finally a user can see the result. That's how your internal architecture is of Hive. Any questions? It's a simple architecture, not so many things. We just need to remember few basic things. So few concepts like client, driver, compiler, execution engine, and underlying. So I think was that person? Someone asked question like was it like where the data is getting processed and about the different ecosystem. So maybe one answer that also. So Hive is a separate ecosystem and Hadoop is a separate thing. Okay, so don't make Sumit. I think Sumit asked the same. Sumit asked the question. I was not able to recall your name. So as the means like Hive is like, so what exactly? Hive is a different ecosystem. Okay, it's a part of Hadoop, means it comes under Hadoop, but it's not actual Hadoop. Ideally, what is Hadoop? Hadoop is two things. What is two things? That is nothing but storage, and storage is done with the help of HDFS. Okay, so Hadoop is comprised of two things. Okay, what are those two things? One is, so storage is done using HDFS, correct? And the second thing is processing. Okay, so processing is done with MapReduce. So always remember this. This is the basic function, core of the Hadoop. Okay, what is Hadoop? Hadoop is storage plus processing. Storage is done by HDFS file system, and processing is done by MapReduce. So Hive is different, Hadoop is different. Yes, but when you are writing SQL-like queries in Hive, underlying data is getting processed by a MapReduce program, which is getting executed in your Hadoop only. Understood, Sumit?
Yeah, Sam, this is Ashutosh. I asked you that question.
Yeah, Shutosh. Yeah.
Yeah, and one question. What is the what of meta store here? Meta store?
There are different types of metastore which we would be seeing. One is local metastore. One we have local metastore. The other is like embedded metastore. The other is remote metastore. There are three metastore. So by default, Hive comes with a Derby metastore. Okay, but it has a drawback. Why it has a drawback? Because Derby uses only single client session at a time. If we want to connect with multiple sessions, we will not be able to do that with embedded metastore. Okay, that's where your drawback comes with your embedded metastore. Okay, so we'll try to see here in Hive, the environment is built using a metastore called database, which is nothing but MySQL. Hence, we can open multiple client sessions and interact in those multiple client session with Hive queries. Okay, so there are three different types of metastore: embedded, local, and remote metastore. So we would be using a metastore that is nothing but the local metastore. Okay, we will not be using the embedded metastore because the configuration has been changed. We would be using MySQL as a database to store that metadata. Okay, and it will be a local metastore. Any questions on this small architecture? Yes, no?
No, sir.
No. Okay, if no questions, then I'll stop my screen share. Okay, I'm just, yeah. Now can you open your edge node or putty? Yeah, beautiful. Yeah, can you, is it possible to increase the font size? Can you just click on, yeah, thank you so much. Change settings, increase the font size to, let's say, 12 or 14, so that other people, I'm able to see, but let's have a smooth experience. Either you can say, yeah, 14 is fine for us, and stop the screen means not stop, hide. Sorry. Okay, let's apply it. Okay, now we know two things, right? If I want to execute my scoop commands, where I execute on my edge node, right?
Yes.
And if I want to open my MySQL database, how I open my SQL database, I know that, right?
Yes.
Okay, now we'll see how to open the Hive terminal. So we just need to type Hive. Can you just type Hive and hit enter? So this is Hive CLI, which means that, remember the client I have shown three options: Hive CLI, the second is Hive Web UI, the third is Thrift Server. Okay, from those three options, I'm showing you the first option. So what is that first option? Hive CLI. It will take some time. Till the time, can you just go to your browser, please? Till the time it is getting opened. No, 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 no. Local. I
Okay.
don't want to see the VM. We are not worried about the VM. Yeah. Can you open? Do you remember the IP address? What is the IP address of your name? Means okay, okay. Can you go to your? Is it like 192.68.511?
Yeah.
Yeah, correct. We so 192.168.21.30. Okay. Can you open one more browser, please? Yeah. Can you type http colon 192 http colon forward slash, yeah, 192.168.21.3, right? Yeah. In spite of 50070 port, can you replace that with 8888?
Okay.
8888. Yeah, hit enter. So with 8888, a web UI which is nothing but you, which is nothing but Hadoop user experience. I hope that port number is correct. Okay, it will open. It is taking time, so let it take. Let it take. I think. Yeah, yeah, yeah. It is coming. Can we see Hive? Okay. So this is a web UI. Okay. So the same queries which we can write on Hive CLI, I can write in this web UI interface also. It's up to us how we want to write the queries or where we want to write the queries. Okay. Can you? The username and password is Cloudera. Cloudera. Can you come to your terminal, the edge node? So I think it should be up. Can you see now? We are getting a terminal called Hive. Can you write a small syntax, show databases semicolon, show space databases semicolon, hit enter. So whatever databases are available, we will be able to see. Okay. So as of now, there is a means. I hope it should be a default database, and there should be. Okay. So you have done something practice. So he has some few other databases also. Okay. If you want to use that database, how we can do? You can write use. Can you write use? And can you just take second database Guru Sumit? Have you created some tables?
I don't know, but I
No
think.
issues, no issues. That is fine. No issues. Hit enter. And can you just write a small command show tables? So are you getting a feel like same like SQL like queries? Same thing we are trying to do. Okay, we don't have tables. That is not an issue. We'll try to start from Monday. So this is the Hive CLI terminal. Okay, the first thing. Can you go to the Hive web UI now? The second option. Can you see? Can you just say never? I don't want to store the password. Yeah, that is fine. Now, can you just see query editors at the top? Top. Yeah, beautiful. Can you just click on the drop down? Yeah. Can you just say Hive? Okay, so there are different engines which Hive, Impala, and etc. which are available. So as of now, we'll try to see the hue. Okay, so you will get the same feelings. Can you see now? We are getting a default database. Under default database, I can see the employee 2, employee, and NID temple. Can you just drag and drop that? Can you just select employee and just drag and drop into the plain area? Yeah, drop it. Yeah, can you just write first thing select star? See, it gives you first, no, select star from. Yeah, that's it. Write that. Yeah, and can you just see there is a execution button, blue icon, left, a radio button. Yeah, so this will execute your query. So this is like writing your queries in a web user interface. Okay, whichever you in comfortable you find, but will not be using this web UI. We will be using the black screen. Understood the second option?
Yes.
Okay, so don't worry if you're not able to see the data. So maybe the data will not be there or something will not be there, but we should be able to see this. Okay, now the third option is Thrift Server. Okay, can you go back to your command line? Can you open a new terminal by doing a duplicate session? Yeah, log in with the Cloudera and maximize the screen. Okay, now the third option is, can you write beeline, Beeline, beeline? So we are trying to connect through a thrift server with beeline. Okay,
Enter.
and
Can you,
huh,
after enter
just
press.
enter, just hit enter. Okay, and once you write beeline, there is a syntax which we'll need to write. Okay, let it enter. So sometime, so I do not see any of the means people have completed the assignments which I gave last week. So I sorry on Monday. So try to complete those assignments, because you'll get to, if until unless you don't do hands on, you'll not get the varieties, because now we have just seen the scope. Those assignments will help you to do something. Those are a little tricky, not tricky. Yes, Manoranjan. Yeah. Drop. I know your call is there. You can drop. So I will be finishing. Just we are almost there to finish. Just I need to show how to log in. Okay. So can you just write exclamation symbol and connect, exclamation, or
And connect.
or let me just type that and give it in the, because it's a long syntax, connect with the JDBC connection hive 2. Then I just need to write forward slash, then I need to say localhost, the port number is 10,000, the username is Cloudera, the password is Cloudera, and with a driver called org.apache.hadoop.hive. I make mistake here only. org.apache.hadoop hive.jdbc.hive driver. So I've just given a, means I've just pinged something on the chat. Can you copy that? And the driver R is missing, so just copy that on the chat window. Can you copy in the notepad before doing that? Can you copy in the notepad? Yeah. Can you just copy? Yeah. Okay, so exclamation connect JDBC Hive 2 server, we are trying to connect with the localhost Cloudera org.apache.hadoop.hive.jdbc driver. Can you just type I at the last? Hive driver. No. I've already written Hive driver. R is missing.
Okay.
Yeah, can you copy this and execute? And let's see if the syntax is correct. Because we always do, generally we in projects we do copy paste, so the syntax, I think the syntax is not correct. So org.apache.gdbc. So let me just pause for a second. Again, I'm trying to send you one, means in the chat box. Can you copy that? Okay, we don't need to write. Okay, that your syntax is correct. Can you go to your terminal and can you just press Control C? So we should come out of this. Yeah, can you hit enter? Can you write beeline again, please? And after writing beeline, can you just enter? Okay, can you just press up arrow couple of times? Yeah. Can you just remove that org.apache.hadoop jo what is there? Only just remove Hadoop. We don't need that Hadoop. Org.apache.hive should be there. Remove that dot as well. Yeah. Now hit enter. That is correct. So that Hadoop, because you have missed the exclamation symbol. Okay, again you
Okay.
need to come out of this control C. Can you come out of, yeah, can you again write B line please? Just remove that Hadoop. Yeah, just remove that Hadoop from the syntax and do copy paste. Yeah, let it come. What is your RAM?
8 GB.
Okay, a little slow. Yeah, can you just paste that command? Yeah, hit enter. Now it is connecting to your Hive 2 and connected to Apache Hive and Zen. Okay, now can you write show databases? Same thing. How we can do in the Hive CLI? Semicolon, semicolon. Can you just type semicolon and enter? Because we are writing SQL like queries, right? And can you just say use default semicolon after default, because SQL like queries. So here you get a tabular format, but in Hive you don't get a tabular format. Okay, can you write show tables? Okay, can you just write select star from EMP2? Let's see, we have some data. Do we have some data? Just trying to test, otherwise that is fine. Yeah, hit enter. Okay, so we can see the data. Okay, so same way how we can see the data in your uh, tables in any relational database, same way we can see the data in Hive also. Okay, we can point these tables to the underlying HDFS file system directories. Okay, and we can see the data in a tabular format in a data warehouse summarization tool which is called Hive. Got it? The three things: Hive CLI, Web UI, and the Thrift Server. Are we able to see these three things? Yes, no?
Yes. Yeah.
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 Okay.